CVN-78 Review. Welcome back. If you love military tech in simple English, hit if you enjoyed this video, make sure to hit the like button, JK Auto Review, share it with your friends, and subscribe to Gerald R. Ford is the lead ship of a brand new U.S. supercarrier class, built to replace older Nimitz-class carriers. She was commissioned in 2017, and since then the Navy has been proving a lot of new systems at full scale. What is CVN-78? B-roll, shipyard and sea trials. Think of CVN-78 as a floating airbase. It carries a full air wing, supports combat operations for months, and projects power anywhere the ocean allows. Being the lead ship means she introduces new technology that future carriers will copy and improve. Key specs: on-screen bullets. Length: approximately 1,100 feet, about 335 meters. Full load displacement: approximately 100,000 plus tons. Speed: 30 plus knots, classified exact figure. Flight deck: redesigned for faster aircraft flow. Crew: ship's company, approximately 2,600, plus air wing roughly approximately 2,000 plus when embarked. These numbers are similar to Nimitz in size, but what's inside is very different. New tech: the big three: B-roll, catapult, arresting wire, weapons elevators. 1. EMALS, electromagnetic aircraft launch system. Instead of steam catapults, EMALS uses powerful electromagnets to launch aircraft. The benefits: smoother acceleration, less stress on airframes, support for heavier and lighter aircraft, including future unmanned systems, and lower manpower and maintenance compared to steam. 2. AAG, advanced arresting gear. The landing system uses energy absorbers and electric motors for more precise control when jets trap on deck. It's designed to handle a wider range of aircraft, again including future drones. 3. Advanced weapons elevators (AWS). 11 high-speed, high-capacity elevators move bombs and missiles from deep magazines to the flight deck. They're designed to be faster, safer, and separated from fuel and air ops, which improves both sortie rate and safety. Other upgrades: on-screen, power, sensors, layout. Electrical power. New A1B nuclear reactors generate significantly more electricity than previous carriers. That powers EMALS, AAG, advanced sensors, and future weapons. Sensors. A modern radar and combat system suite improves situational awareness and reduces crew workload. Deck layout. Wider island, fewer obstructions, and better taxi routes for aircraft. All of this shortens the time between launch and recovery cycles. Air wing and sortie rate: B-roll, FA-18, E-2D, MH-60, F-35C, MQ-25 renders. The Ford can typically host 75 plus aircraft depending on the mission: FA-180F Super Hornet, EA-18G Growler, E-2D Hawkeye, MH-60RS helicopters, and increasingly F-35C stealth fighters. It's also designed with unmanned aircraft in mind, like the MQ-25 Stingray tanker. Thanks to the deck redesign, EMALS, and faster weapons flow, the Navy's goal is significantly more sorties per day than a Nimitz under high-tempo operations. Power and crew: on-screen, smaller crew, more automation. Ford-class automation reduces the ship's crew by several hundred sailors compared to a Nimitz. Fewer people doing repetitive tasks means lower life cycle costs and more room for maintenance and training. The extra electrical power also leaves headroom for future systems such as directed energy weapons or more advanced sensors. Costs and challenges: B-roll, maintenance, testing. Let's be honest, being first is expensive and messy. CVN-78 had high initial costs and teething problems, especially with EMALS, AAG, and weapons elevators. Fixing and certifying these took time. That's the trade-off of a lead ship. You pay more upfront to push the technology forward, so later ships can be cheaper and more reliable. What it means: B-roll, carrier group at sea. Operationally, a Ford-class carrier brings more launches, quicker turnarounds, and better support for stealth and unmanned aircraft. With longer-range missiles and network warfare, the carrier remains a central piece of sea control and power projection, now with greater electrical capacity to evolve over decades. Verdict: on-screen. Pros, cons. Pros: next-gen launch and recovery, faster weapons movement, higher sortie potential, reduced crew, huge electrical margin for future tech. Cons: high cost, long debugging period, complex new systems. Bottom line: USS Gerald R. Ford is the blueprint for how carriers will operate in the 21st century, built not just for today's jets, but for tomorrow's unmanned and high-energy systems. Outro: call to action. If you enjoyed video, make sure to hit the like button, JK Auto Review, share it with your friends, and subscribe.